Hello everyone. In this video the topic is photoelectric effect. It's a very important topic. It is very useful for all the CBSE students, +1 students and the intermediate of Telangana and Andhra state students, and it is also useful for all competitive exams. This is a part of atomic structure in the chemistry chapter, photoelectric effect. For understanding this photoelectric effect, what is the terminology required? Here the students must have the knowledge on the terminology threshold frequency and threshold wavelength, stopping potential and work function and the intensity. We will explain every term during the concept. It is not possible to explain the terminology before the concept. In this video we will cover the definition and experimental explanation of the photoelectric effect and mathematical relation of the photoelectric effect and graphs which are related to the photoelectric effect. Why we are studying the photoelectric effect? To explain the particle nature of the radiation or light, photoelectric effect supports. The photoelectric effect supports the particle nature of the light in addition to Compton effect. And what is the significance of the photoelectric effect in our life? Solar power, generation of electricity by using the sun radiation is due to the photoelectric effect, right? That is the application. Come to the definition of photoelectric effect. Before to enter into the definition, student recall the concept. I am taking a metal surface. For better understanding, I am taking a one metal atom. This is the nucleus of the metal atom. Suppose this is the outermost orbit of that metal atom, right? This metal atom is under the, this metal atom has electrons in the outermost orbit. Suppose all these electrons generally under the influence of the nuclear attraction. These electrons are under the influence of the nuclear attraction, right? This is the source of light, source of light. From here, radiation falling on the or hits the electron. This light from this source, light fell on this electron of the particular given atom. If this electron, after absorbing the energy, it will be excited away from the total nuclear attraction. That phenomenon is called photoelectric effect. I am repeating. When radiation falling on the metal surface, the electrons are excited and ejected out from the nuclear attraction. That phenomenon is called photoelectric effect, and the electron which is obtained called photoelectron. The ejected electron is called photoelectron. Simply you understand, the light falling on the metal surface, then these electrons absorbed that energy and excited out from the nuclear attraction. That phenomenon is called photoelectric effect, and this electron is called photoelectron. This is the definition for the photoelectric effect. Here a doubt arises. This is one atom having the nucleus. This is the another atom having the nucleus. Suppose this is the small atom and this is the larger atom. Suppose this is the condition A, this is the condition B. Suppose here one electron in the outermost orbit, here one electron. Nuclear influence on this outermost orbit in A and B, if you compare, here nuclear influence on this orbit is more, on this orbit is less. On this orbit is less. That's why it easily ejected out. That means photoelectric effects needs the larger atoms. Larger atoms or with lower nuclear attraction. Lower nuclear attraction. So this is the condition is required to construct the photoelectrical cells. Larger the size of the metal atom, nuclear influence on the outermost orbit is less, so it easily ejected out from the metal surface. The electron liberated in this process is called photoelectron. This is the basic definition of the photoelectric effect. Students, now we will discuss this photoelectric effect by taking experimental devices. Come to this one, Hallmark experiment. First look at the construction of the experiment. Construction of the experiment. In this experiment, this is the cathode and this is the anode, and it is a vacuum chamber. Vacuum chamber. Here this is the area allowed radiation from some source. This is closed with the window. This window is closed with the glass. That glass particularly quartz. Why we are using the quartz glass? Quartz glass will never absorb the energy of the radiation passing into the vacuum chamber. If you are using glass window instead of the quartz window, it absorbs some of the radiation. The result is not calculated properly and accurately. To avoid that, we are made that window with the quartz. Quartz is unable to absorb the radiation or energy of the falling radiation, right? In this experiment, before allowing the radiation into the vacuum chamber, first observe the construction. This is the cathode and this is the anode. It is a complete battery, and this battery is having some galvanometer to show the current flow or deflections. Generally current flow is observed by noticing the deflections in the galvanometer, right? Look at this. But it is not a, it is the cathode, it is the anode, it is a vacuum chamber, there is a no current flow, right? Now you allow the radiation. You allow the radiation from the source through this quartz window. Whenever this radiation falls on this cathode, it is made up of a metal sheet. Generally that metal of the lower ionization potential, or this metal sheet having larger size in order to release the electrons readily, as discussed earlier. When the radiation falling on this cathode plate, electrons are ejected due to the photoelectric effect. What is the proof? This cathode is negatively charged, this anode is positively charged. Because of radiation of because of falling of radiation on this sheet, electrons are ejected out. Generally electrons are negatively charged, they travel towards the anode. This will be noticed by observing the deflections in the galvanometer. That means electron flow indicates current flow. Of course, directions will be different. Whenever the electron is flowing from cathode to anode, current flow will be noticed by observing the deflections in the galvanometer. Whenever you are stopping the radiation falling on the cathode ray from the external source, the deflections in the galvanometer becomes 0. When again you allow the radiation, that means light, here galvanometer deflections will be noticed. That means here light will generate the electricity. So such cells are called photoelectrical cells. Photoelectrical cells. Photoelectrical cells. Right? These electrons are traveling. The traveling electrons have some kinetic energy. This is called kinetic energy of the photoelectron is equal to half mv square. Why the electrons are traveling from this cathode to this anode? Due to the charge difference. Due to the charge, it has a negative charge and it has a positive charge, and also have the potential difference. The potential difference is V and the charge is E. So this is called E and V is E is called charge on the electron, V is the potential difference between the two electrodes, right? These electrons will travel and hit this anode, because anode has the positive charge. Suppose you want to stop this electron to hit this anode, you want to make the kinetic energy of the electron equal to 0. In another word, this kinetic energy is equal to 0, right? For getting that 0 value, you will apply some potential against the electron. That potential is called as V0. This is called stopping potential. Stopping potential. Right? The electron which is traveling from cathode to anode have the kinetic energy of mv square, or the charged potential is EV. The potential which is applied to stop the electron flow is called stopping potential. Therefore, of mv square want to be 0, you have to apply EV0. EV0, V0 is called as the stopping potential, E is the charge carried by the particles. How can you calculate the stopping potential? V0 is equal to half mv square by charge of the electron. I am repeating, electrons are flowing from cathode to anode. To stop these electrons, you made their kinetic energy is equal to 0. Their kinetic energy is equal to half mv square, that is equal to EV. Half mv square is equal to EV. The potential which is required to stop that electron is particularly called as stopping potential. Stopping potential is equal to half mv square by E. This is the way to calculate the stopping potential. And mathematical relation, look at this. This is the nucleus. Assume it is the outermost orbit. Here is electron is there. This is the source. right? If the radiation falling on this electron, if the radiation falling on this electron is ejected out in general, but this electron is under the influence of the nuclear attraction, right? Suppose this nuclear attraction, to overcome from this nuclear attraction, certain amount of energy is required. That energy is called work function. That energy is called work function. The energy which is utilized to remove the electron from the nuclear attraction is called work function. Work function is denoted with W. It is equal to h nu naught. Here the radiation falling on this electron, its energy E is equal to h nu. Here h is called Planck's constant. Nu is called frequency of incident radiation. Incident radiation. And nu naught is equal to threshold frequency. Threshold frequency. What is the difference of the frequency and threshold frequency? This electron is under the influence of the nucleus, right? To overcome from this nuclear attraction, this requires certain amount of energy. That utilized energy is nothing but wave function. Wave function is represented with consumed energy. The heated energy is h nu and consumed energy is h nu naught. This is called frequency of this radiation. Nu naught is the frequency of the radiation consumed. We will call it as threshold frequency or critical frequency, right? For the convenience, I will explain with the numericals. Work function required is 10 electron volts. Suppose the incident radiation is 25 electron volts. Suppose electron ejected out is called photoelectron. This photoelectron has some kinetic energy. What is the value of kinetic energy here? It strikes this incident radiation strikes this metal surface and its energy is, let it be, 25 electron volts. Students, you have to assume generally the incident radiation may be utilized in a different ways, in different work processes. Collision, some of the energy is utilized for collision and some energy is utilized for excitation, but here we considered all the energy is utilized only for two purposes. One is for the work function and another one is the kinetic energy. You will be neglected all the remaining processes, right? Right. You remember that point. In case of our chemistry, we consider only the work function and the kinetic energy. But in the physics part, you will discuss certain amount of this incident energy will be consumed as collision energy also. But we are neglecting all the things, right? 25 electron volts and 10 electron volts is for work function. It is characteristic for every metal atom, metal surface, type of the metal. 20 among the 25, 10 is consumed. How much is released? 15. So here kinetic energy is 15. What is the mathematical relation here? 15 is equal to 25 minus 10. We made some mathematical relation here. 15 means kinetic energy, 25 means energy of the incident radiation, 10 means work function. So this is the relation for the photoelectric effect. We will make some more relations. Wait. From our explanation, it is clear that kinetic energy is equal to energy of the incident radiation minus work function, right? Kinetic energy Ke is equal to energy h nu minus work function h nu naught. Kinetic energy Ke is equal to h into nu minus nu naught. This is one relation you have to make, right? Here nu naught is the threshold or critical frequency. Right. Kinetic energy Ke is equal h into c by lambda minus c by lambda naught. Since lambda is equal to c by nu from the basic knowledge of the light, Ke is equal hc into 1 by lambda minus 1 by lambda naught. What is called lambda naught? Critical or threshold wavelength. Threshold wavelength or critical wavelength. Finally, kinetic energy is equal hc into lambda naught minus lambda by lambda into lambda naught. Look at this. Kinetic energy means half mv square is equal to hc lambda naught minus lambda by lambda into lambda naught. V square velocity is equal to hc 2hc by m into lambda naught minus lambda by lambda into lambda naught. Finally, V is equal to 2hc by m into lambda naught minus lambda by lambda into lambda naught whole power 1 by 2. This is the relation between the velocity of the photoelectron when the wavelength and their threshold wavelengths are given. And one more formula I am recalling, half mv square is equal to EV naught. This is the stopping potential. Here V square is equal to EV naught by m. Therefore, V is equal to 2 EV naught by small m whole power 1 by 2. This is also velocity of photoelectron. When the stopping potential is given. This is the V, this is the V naught, V naught. This is called stopping potential. Stopping potential. Right? These are the all our mathematical relations of the photoelectric effect. Come to the graphs. Very simple, students. Kinetic energy versus frequency of incident radiation asking. What is the formula? Ke is equal h nu minus nu naught. This is the relation. So here we are taken nu value. Here we are taken kinetic energy. Automatically slope is equal to h. Planck's constant. You are getting the graph like this. Right? Here is the nu naught and here slope equal to h. As the frequency increases, kinetic energy of the radiation increases. I will explain how it increases. If you take the nucleus and also taking the nucleus, two examples. This is the atom, both the atoms will be same. This is the source. Here electron is there, here electron is there. Both the atoms are same. Both the atoms are same. Here it falls on this one. This radiation falls on this one. Suppose this is the radiation A, this is the radiation B. This electron under the influence of this nucleus, this electron is under the influence of this nucleus. Both the atoms are same, both belongs to same nature, so their work functions are same. For the sake of convenience, I am taking 10 electron volts. Here also 10 electron volts. This A radiation has energy of 15 electron volts. Here radiation B has 25 electron volts. Suppose here electron is ejected out, here electron is ejected out. This ejected electron is called photoelectron. This is called photoelectron. It has a kinetic energy of 5. It has a kinetic energy of 15. Right? Whenever the energy of the incident radiation h nu increases, kinetic energy increases. H nu increases, kinetic energy increases. Here h nu value is 15 electron volts, so kinetic energy is 5. Here h nu value is 25, so kinetic energy is 15, and constant value is threshold frequency. So this is the utilized as this part is utilized as threshold, right? From there, as the frequency increases, the kinetic energy increases. So such a graphs will come out. Understood? And come to the kinetic energy versus intensity of incident radiation. I will explain. Here also I am taking this is the nucleus. Suppose this metal surface, this particular atom, for the sake of convenience, 5 electrons are there in the valence shell. Same atom is taken. For the convenience, I am taking 5 electrons again. This is the source. From this, for the sake of convenience, this is the condition B, this is the condition A. In the condition B, one radiation will hit this metal surface and the electron is ejected out. This it's here every electron under the influence of nuclear attraction, and the work function is equal to 10 electron volt. Suppose here I am using 120 electron volt energy radiation. Then kinetic energy of the photoelectron is 110 electron volts as per our previous explanation. In this case, I am using 5 radiations all radiations have same energy. Every photon will hit one electron. Here every electron under the influence of nucleus assumed to be 10 electron volts. Energy is required to remove this electron from the nuclear attraction. Here 20 electron volts of radiation falling, 20 electron volts of radiation, 20 electron volts, 20 electron volts, 20. That means all the radiations have the constant energies. Then what happens? 5 electrons will be ejected out. 5 electrons will be ejected out. So kinetic energy of every electron is 10 electron volt per electron. 10 electron volt per electron. Right? So here we are using only one radiation. We are using one radiation, its energy is 120 electron volts. So here kinetic energy is 110 electron volts. Here we are using 20 electron volts, kinetic energy is 10 electron volts, right? So this is the similar explanation as we discussed here. But here the different point is, we are using how many photons? 5 photons, right? These 5 radiations will liberate 5 electrons. Suppose in this experiment we are getting 10 electron volts per electron kinetic energy. Suppose you are using the 6th photon and the 6th electron is there, suppose. What is the kinetic energy? 10 electron volts. If you are taking 10 photons or 10 radiations or 20 radiations, the kinetic energy will never change. Kinetic energy changes with the energy of the radiation. Kinetic energy will not changes with the number of radiations falling on the metal surface. Number of radiations falling on the metal surface will not influence the kinetic energy. So kinetic energy is independent of the number of radiations hit the metal surface. Number of radiations means intensity. So intensity, kinetic energy is independent on the intensity of the radiation. So we are getting the graph like this, parallel to the, if the intensity increases, kinetic energy constant. If the energy of the incident radiation increases, kinetic energy increases. If number of photons increases, number of photoelectrons will increase. Number of photoelectrons will increase, but the kinetic energy of the photoelectron remains constant. So intensity, kinetic energy is independent on the intensity. So this is the graph obtained. This is the kinetic energy versus frequency. This is the kinetic energy versus intensity. This is all about the photoelectric effect for the CBSE level 1 students. If any students have the doubt or the requirement, please comment in comment box. Please subscribe my channel in order to share the subject with the majority of the students, and please like it. Thank you very much.